to the first video for my modular synthesizer. Like so many projects, this started out as something completely different. Ever since I was a child in primary school, I wanted to build an SN76477 based synthesizer. These chips were easily available in the early 80s and were fairly well documented. These chips were featured in numerous magazine articles during the early 80s, including this one from ETI August 1981. There don't seem to be any good quality data sheets available anywhere, but these have been obsolete for quite a few years, so I'm not surprised. The data was good enough though, and I was able to find enough information to design a simple synthesizer using it. I also had grand plans of an analog keyboard to make it playable. At the time when I made it, I didn't think it was worth taking any videos, though it was a bit messy and awkward to solder, so it would have been interesting. It did make some interesting sounds, but was surprisingly difficult to get good sounds out of it at times. As you can see, the circuit is great for creating interesting sound effects, but it doesn't seem to be very practical as a musical instrument. One very important lesson that I have learned from this project was that I like the idea of making a synthesizer. So now what? Moritz Klein. If you're looking to design analog synth equipment, his videos are brilliantly made and his modules are cheap to make and they are great quality designs. I won't post any schematics here, since you can go to his YouTube channel and get the schematics from there. Don't expect it to be quick though, because you will get drawn into learning a ton of useful stuff. This is my perf board layout for Moritz Klein's VCO. It's a nice small board and relatively tightly packed. The component values are not shown as they will only appear when the mouse is hovered over a part. These 3D printed frame parts feature a snap-in mount for the perf boards and colour-coded panels to make it easier to find the dials that you're looking for. Here is one of the modules that had been partly assembled. The pins to the right are some random ones that I've had hundreds of. I use these in place of jack plugs and sockets, as a particular size of ferrule pin plugs in perfectly. I very much went away from Eurorack for this, but purely for cost saving. Electrically, I have adhered to it so I can go Eurorack in the future and just patch across. Here is my VCO hooked up to an oscilloscope. You can also see a ferrule pin being used on a patch cable. But then something happened. I felt like a change whilst I was testing and fixing the modules and did a Google search on ESP32 and synthesizer. This was just a 5-bit diversion, or so I thought. But I stumbled across AMI and almost immediately sidelined the analog modules. So, all I need to kick this project off is an ESP32 and an I2S DAC. So, I designed a simple stereo DAC. As you can see, it's really simple, based on designs taken straight from data sheets. I think the parts cost $15 all up. What could possibly go wrong? Here I am using the ESP8266 audio library by Earl Filhauer, because it provides a number of additional functions for things that you would commonly use I2S for, such as playing MP3 or Amiga mod files. This problem took weeks to fix and I nearly gave up. I immediately ordered a different DAC. I tried removing the level conversion. I tried some different amplifier configurations. I tried different pins on the ESP32, and when the new DAC arrived I tried that and that failed. Nothing worked. So out of desperation I thought maybe the jumper wires and breadboards can't handle the transfer speed. So I doubled up on the data connections to see if that reduced the electrical noise and fixed the problem. It worked. Work commenced on the new synthesizer module. AMI can be configured by working with data structures or sending commands to it through ASCII coded messages. I chose the ASCII messages because it provides a lot of useful capabilities. For example, ASCII coded messages are easy to load and save. The synthesizer could be configured over Wi-Fi, and messages could be printed to serial for debugging. And here is the prototype. Those who are familiar with my other videos may recognise the LCD display from my MUT project. It did actually use the menu system from the MUT as a foundation for this project. Just above the LCD you will see a perf board with only a single breakout board plugged into it. This is the DAC. As I will need to change it in the future, I socket it so it could be reused. The 5 menu buttons are actually M3 screws connected to the ESP module using touch inputs. It works remarkably well with absolutely no debounce logic required. The DB9 connector will be used in the final version for connecting external inputs such as a keyboard or potentiometers. Next is the world's worst 1-octave keyboard. It is really quite useless except for testing. Here are the 16 potentiometers that can be configured in the menu to control different settings in real time. Lastly, this is the main interfacing system for all external inputs from keyboards and analog sources. This is a close-up of the interfacing electronics. It uses a PCF8574 so that the ESP32 can use I2C to select the source. 3 of the 8 bits from the PCF8574 are fed to a 4051 analog multiplexer, which allows one of 8 data sources to be selected. The last 4 bits of the PCF8574 connect to a bus that controls up to 8 4067 16-channel multiplexers. If an 8 was sent down the 4-pin address bus, every one of the 4067s will connect its 8th input to its output. The output of each 4067 goes to a different input of the 4051, which is then used to select which of the 4067s it is monitoring. The ESP32 just sends an address number via I2C, then uses an analog input to read the signal. Here is the prototype potentiometer board with 16 potentiometers and a 4067. Here is a close-up of the knobs on the potentiometers that also shows the red indicator needles as well as the black graduation markers. The final design will use smaller knobs and graduations as this is quite cramped. Once I was happy with the prototype, I recreated the design in KiCad and then had a set of boards made by JLC PCB. These were so much faster to assemble than the prototype panel. We have a photo of the new potentiometer board fitted with the new low profile knobs. These knobs also feature changeable centers that allow them to be identified by colour. There is a menu that shows all 16 potentiometers including the setting. In future videos I will cover some topics in more detail, such as the electronics, the ESP32 firmware, the PC configuration app, PC patch importer app and the PC synth tracker app.